Let's talk about limiting reagents. This is really the whole basis of chemistry, the empirical stoichiometric combination of two or more elements. This is what the whole of the law of conservation of mass is about. So, remember the premise behind limiting reagents? That in a chemical reaction, one reactant always runs out first, and the reaction stops. There are three steps to solving a limiting reagent problem. First, we have to figure out which is the limiting reagent. Then, we have to figure out the amounts of each reagent that we have. And finally, we figure out how much product can be made from the amount of limiting reagent.
Okay, let's work a limiting reagent problem. Silver nitrate and aluminum chloride react according to the following reaction equation. 3 silver nitrates plus 1 ammonium chloride yields 1 aluminum nitrate and 3 silver chlorides. What mass in grams of silver chloride is produced when 4.22 grams of silver nitrate react with 7.73 grams of aluminum chloride? Okay, what's the first thing you notice about this problem? Of course, it's that the reaction information is given in grams. And as we all know, you can't work a stoichiometry problem in grams. So what we want to do is use the equality that gives us a conversion factor between grams and moles. Remember that one? Of course you do. It's that the molar mass of any element or compound is equivalent to 1 mole of that material. The molar mass of any element or compound equals 1 mole of that material. Remember, we said that this molar mass can be thought of as the molecular weight or the formula weight. Remember, we said that those terms are generally used interchangeably, and you get this molecular weight simply by adding up the atomic weights from the periodic table of the atoms that make up the compound. So now we have this equivalent statement that can be used to make a conversion factor. Just as with any conversion factor, you write down what you know and you multiply it by a conversion factor. Put on the bottom what you started with and bam, there's your answer. All right, now what numbers is it that we need to replace with moles? Here is 1 gram, and here's another gram number, and those have to be made into moles. Okay, so again, we're going to write down what we know, then we're going to multiply it by a conversion factor. Okay, what we know of the silver nitrate is that we have 4.22 grams, and be sure to tell what it is. Silver nitrate, and we're going to multiply that by our conversion factor with what we started with on the bottom, which was grams of AgNO3. Now, this conversion factor says that the molar mass, which is going to be in grams, of silver nitrate is equivalent to 1 mole. Good. Okay, now where do we get this molar mass from? Right off the periodic table. Pick the atomic weight of all the elements in AgNO3 and multiply them times the number of times that they occur in that compound. Oxygen appears 3 times, nitrogen appears once, silver appears once. Add those together and you get the molecular weight. Silver weighs 107.86. Nitrogen weighs 14, oxygen weighs 16 about, 3 times 16 plus 14 plus 107.86 is 169.86. 169.86 grams of silver nitrate is the same thing as 1 mole of silver nitrate. And the grams of silver nitrate are going to cancel, and 4.22 divided by 169 is 0.0248 moles of silver nitrate. All right, what's the other thing that we have to change to moles? 7.73 grams of aluminum chloride. Write down what you know. And multiply it by a conversion factor with the molar mass on the bottom and moles on top. The molar mass of silver chloride is, silver is 26.98, chlorine 35.45. There are 3 chlorines. 3 times 35 is about 106. 106 and 26 is 133.34. 133.34 grams of aluminum chloride is equivalent to 1 mole of aluminum chloride. And the grams of aluminum chloride cancel, and we end up with 7.73 divided by 133.34, and that gives us 0.0580, 0.0580 moles of aluminum chloride. Okay, let's just go ahead and replace those grams with moles. And that would be 0.0248 moles of silver nitrate and 0.0580 moles of aluminum chloride.